So hello guys, welcome to my YouTube channel Data Stories. So in the previous session we have started a course called machine learning. So we have covered a lot of part of it. So in the previous lecture we have studied the evaluation parameter of logistic regression. So in this video we are going to see the practical implementation of it. So let's start. So firstly you have to go to Google, visit kaggle.com and type in the search box, type hard disk dataset. Then you have to download this dataset, right? So I have downloaded this dataset. So you can follow this step and download the dataset. After downloading it, you have to load the dataset in the Jupyter notebook. So open the Jupyter notebook, click on upload dataset. Okay, as you can see that the dataset has been uploaded. Now create a new Jupyter notebook file and start writing the code. So I will rename it as art. This is using logistic regression. Okay. So first of all, we have seen in the linear regression that we first import the necessary libraries. So first of all, we will import the necessary libraries. Import numpy as np. Numpy is used for arrays. Import pandas as pd. Pandas is used for data analysis task. And I want to see the all the rows and columns, so I will write the code pd dot set option display dot max column nominal. Same I want to see for rows, right? So I will copy it and I will paste it here. I will suggest you to don't just watch the video, do it side by side with me. So you will get a hands-on practice with it. So I will run this. Okay. So importing necessary libraries. Okay. So the next task is to load our data set and to see what content is it. So I will create a variable called tf. I will write pd dot read csv is the function. And what was my data set name that I have saved here? That is heart. The same you have to give it in double inverted heart dot csv. So tf dot head will give us the first five column. And if you want to see more column, then you have to specify the column that you want to see here. For example, I want to see the first six columns, right? So I will write here six and I will run. So you can see that the first six columns are visible. 1, 2, 3, 4, 5, and 6. So as you can see that in the data set, age column is there, the sex column is there. This is something CP is there, and other columns are there, right? So our main aim is to predict the target column, right? So we have to predict if the patient has disease or not. This is the main column that we have to predict. So as you can see that here, all the columns are in numerical format. It is good for us. If it is in categorical, then we have to use label encoder. but we have to not use label encoder now because all of the columns are in numerical type. But I will show you how to use the label encoder in this video, because if in future you got something categorical column here, you have to convert it into numerical one. So the best option is to use label encoder. Okay, so now we will do the data pre-processing step. Data pre-processing. So now we will check how many rows are there, how many columns are there. So a dot, so df dot info. So I will run it. So you can see that there are total 13 columns are there, and there are no null values in this. If there are null values, then we replace numerical columns by mean and categorical columns by taking mode. I have shown you how to fill the null values in my previous practical part of linear regression. You can watch that video to clear the concept. Otherwise, I have told you in this video that how to convert it. Okay. So there are no null values. So we have to don't fill it. So the next step is to check the size of the data set. df dot size. Just a second. Okay. Total size of the data set is 14,350. Okay. So now I will show you how to use the label encoder. So you have to form a sklearn dot pre-processing import label encoder, create a variable li, type the function label encoder, and the main point is that if one column is category, for example, this cholesterol column is categorical, we have to convert it into category. You have to convert it into integer, right? So we will apply label encoder to all other columns, not just the one column. It's just a precautionary measure we are taking so that none of the other column remain categorical. As the null values are there, if they are categorical, it may create problem. So I will not run this cell because all the columns are in numerical type. Just I am showing you the syntax. df df dot select d types include object column. I will apply it to all the columns equal to df dot select d types. The same we have to copy include object dot columns. So I will copy it and I will paste it here. Dot apply. This is the main step. Lead dot fit transform. Okay. So this is the code to convert categorical column into numerical one. So I will not run it. It's just for your understanding purpose. Okay. So the next step is to build a model, but before that we have to do sampling, right? So the next step is sampling. Sampling means we have to divide our data 80% in test and 20% in train, right? You guys can correct me if I spoke something wrong. Okay, I have I have told you that we are giving 80% in train and 20% in test. Hope those who are listening to my lecture can spot the error. This was tricky one. Okay, so let's proceed from sklearn dot model selection import train test split x test x train equal to train test split actual data set name variable name and test size 20% we have to give in test. So test size equal to 0.2. So I will run it. Why it's taking a lot of time. Okay, we will wait till it gets run. Okay, you can see that it gets successfully run. So now we will divide our data into train and test. So as you can see that this is our target variable, right? Okay, so we have to fetch this into target variable. These are all the x variable. I will call this as x variable, and this is y. This is target variable. So we have to separate this column. So I will write one code a train x equal to x train dot ilog is the function. This is select all the rows tell but don't include this target column. It will select all the rows and all the columns, but excluding this target column, right? Okay. So a train y equal to x train dot ilog. So in this we want our target variable. So all the rows and target variable should be included. So I will run this cell. The same we want for testing. We'll copy it and paste here. Just the difference is that we have to write here test. So I will run it. So now we have successfully splitted our data into train and test. Now the next step is of model building. So model building from scalar dot linear model import Logistic regression. I will assign it to a variable logistic regression. Now I will use the fit function to train my model. So a train x, comma, a train y. So I will run this. So as you can see that a model has been successfully created. So now I will use predict function to predict the values. I will d dot predict. So always remember that while doing prediction, use only test values, not train values. Okay, so a test x, right. These are all the prediction. So now we create the confusion matrix from a scalar dot matrix import confusion matrix confusion matrix a test y comma prediction values. Okay, so these are the evaluation parameter confusion matrix, recall score, precision score, F1 score, AURFC curve that we have covered in the earlier video. If you want to know the concept, you can watch my earlier video. In this video, we are just doing the practical part. Okay, so as you can see that the confusion matrix has been created and the confusion matrix look good. So now we will check accuracy score from sklearn dot metric import accuracy score accuracy score test y comma right. So 82%, it's a good accuracy score that we are getting. So I will copy this, I will paste it here, I will just write it here, recall score, recall, recall. So I will run this. 86%. Again, it is very good. Okay, if we don't get these good values, if I run this, if I get accuracy around 20%. So what we have to do, we have to tune the model. Okay, so that we will cover in upcoming part how to tune the model if we don't get good accuracy. There are a lot of technique like oversampling, undersampling, hyperparameter tuning that we will cover in the next videos. So stay tuned. So next we will calculate precision score. Okay, again 81%. It's a good score. So now F1 ratio. Guys, I am copying it because I have practiced a lot. You are beginner, you have to write it by yourself each line. So please don't copy as it is. Do it by yourself. F1 score. So after one score, so I will run it. Again, 83%. It's a good F1 score. Now we will plot AUROC curve. AUROC curve. Okay. So red proba. We want the prediction probabilities. So D dot predict proba A test A test X proba. So now we get the prediction probabilities. Okay. Now you can see here the two values at 0.28 and something and 0.71 something, and here you can see 0.63 something and 0.36 something. If you add these values, you get the value of 1. If you don't get the value after adding 1, means something is wrong, then you have to look at it. Okay, so the next one from sklearn dot matrix import ROC AUC score from sklearn dot matrix import ROC curve ROC AUC score A test Y comma pret. Okay, 82 82%. It's quite a good score. Now after this, it's your wish to plot the AUROC curve. If you want to plot it, you can plot it. Otherwise, you may skip it. But we will plot it in this video. So FPR, comma TPR, comma THER, ROC curve is the function A test by actual values, comma red proba that we have calculated in the previous step. So we want only class 1 records. Okay, I have done this because I want only class 1 records. Don't get confused. I've done it and import matplot lake dot py plot adds plt dot plot fpr comma tpr. So let it get run. So as you can see that we have successfully plotted the AORC curve. It is 82%. This value comes in between this region, this 82%. So that's all about this video. In this video, we have seen the logistic regression practical part. The theory part was covered in the earlier video. So if you want to watch the theory part of logistic regression and evaluation part, you may watch my earlier videos. Okay, so thank you for watching this video. I will see you next time.